Hello everyone, welcome to this lesson. Today we will solve some problems on square and square roots. Let's begin. Let's look at the first question. Find the value of root 5 correct to two decimal places. Then find the value of the square root of 3 minus root 5 by 3 plus root 5. Correct to two places of decimals. First we have to find the value of root 5 correct to two decimal places. Let's do that. So first let's find root 5 correct to two decimal places. So square root of 5 correct to two decimal places means we have to, if we are using the division method, then we have to take 3 pairs to the right of the decimal place, right, to round it off to two decimal places. So let's do it. So we have paired the decimal places and then we have 5 alone in the integral part. So first, what is the number that I can square to get 5 or less than 5? So that will be 2, because if I take 3, 3 will be more than that. So 2 2s are 4. When I subtract, what will I get? 1, and we have to add the same number that we have multiplied. So plus 2 will give us 4. Now we'll bring down the first pair, the decimal part, and put a decimal point here. Now what number should I take with 4 and multiply the same to get 100 or something like that? So let's take 2 2. So 2 2s are 4 and 2 4s are 8. So 84. We cannot take a bigger number, so we have taken 2. So we have 16, then carry down 2 zeros, then add the same 2, it will become 44. And what number should we take here and multiply the same to get 1600 or less than that? Let's take 3. So 443, 3 times will give us 1329. Let's subtract. So what will we get? 2 1 is 7 and 2. So 271, then we'll carry down the 2 zeros. Now we have to add the same number that we have multiplied here. 3, it will give us 446. Now what number should I multiply here? What number should I take here and multiply the same to get 27,100 or something like this? Lower than this. Let's take 6. So 6 times will give us 26796. So let's subtract. We'll be left with 304, that is 304. Now we have divided the 3 pairs after the decimal places. So 3 decimal places we have got. So we can round it off to 2 decimal place now. So square root of 5 will be 2.24, right? Square root of 5 is equal to 2.24, rounded off to 2 places of decimal. Clear? So we have found the square root of 5, that is 2.24, rounded off to 2 places of decimal. Now the second part of the question asked us to find the square root of 3 minus square root of 5 by 3 plus square root of 5. Now we can substitute the value of root 5 that we have got. So you have to find the square root of 3 minus, what is the value of root 5? 2.24 by 3 plus 2.24. Now 3 minus 2.24 will give you 0.76, and 3 plus 2.24 give us 5.24. So you have to find the square root of this. Now let's try to remove the decimal. So here we have 2 decimal places in the numerator and 2 decimal places in the denominator. So the decimal places will get cancelled, or simply we can say, if I change the decimal number 0.76 into a fractional number, it will become 76 by 100. And same for the denominator, 5.24 will become 524 by 100. So 100 gets cancelled. So let me show it to you. So 76 by 100, and we can write it as 100 by 524. So down, I have taken down the decimal place, so by 100 and 76 by 100. So 100 gets cancelled, so we are left with square root of 76 by 524. Now let's reduce it further. So 76, 4 19s are 76, and 4 131s are 524. So we have to find the square root of 19 by 131. Let's simplify this further by dividing 19 by 131. So after dividing 19 by 131, we'll get square root of 0.145038. Now why did I find 6 decimal places? Because we have to find the square root of 3 minus root 5 by 3 plus root 5 correct to 2 places of decimal. In the question it was given, right? So I have simplified it into 19 by 31. So after dividing, it results in decimal numbers. So finding the square root of the decimal number to 2 decimal places, we need 3 pairs. That is the reason why we have found 6 decimal places after dividing 19 by 131. Now let's find the square root of this number. So here 3 minus root 5 by 3 plus root 5, we have transformed into a simple decimal number so that we can find the square root. So let's find the square root of 0.145038. So let's make the pairs. So in the integral part we have 0. So in the decimal part, let's start from left to right. So first pair is 14, then 50, then 38. So let's start dividing this 0. What will be the number that I'll square to get 0? 0 itself. So 0 zeros are 0 will get, and you subtract, you'll get 0 here. So plus 0, that means 0 only, nothing. So we'll carry down 14. Now what number should I square here and multiply the same, right, to get 14? Now this number 14 is after the decimal, so we'll put a decimal point. So 3 times is 9, 4 4s is 16. So we cannot take 4, we have to take 3. So 3 is a 9 we will get. We'll subtract 14 minus 9, we'll get 5. We'll carry down the next set, that is 50, and whatever we have multiplied, let's add it. So 3 plus 3 will give us 6. Now what number should I take here and multiply to get 550? Let's multiply, let's take 8 and multiply by 8. What will we get? 544. Let's subtract this. So we'll be left with 6, and then we'll bring down 38. Now we'll add the same number that we have multiplied there. 68 plus 8 will give us 76. Now what number should I take? Now see, if I take 1 and multiply by 1, we'll get 761, but still it is more than this, so we cannot do that. So we'll multiply by 0. 760 multiplied by 0 will give us 0, right? So we still have 638, but we have already divided the 3 pairs that we took to round it off to 2 decimal places. So now if we round this square root of this to 2 decimal places, what is the number? 0. So the number 8 will remain the same. So square root of 145038 is equal to 0.38 rounded off to 2 places of decimal. Here. So finally we can say, therefore square root of 3 minus root 5 by 3 plus root 5 is equal to 0.38, which is rounded off to 2 places of decimals. Clear? Next question. Find the least number by which 10,368 should be increased and decreased to make it a perfect square. So first we have to see which number should be added to this number to make it a perfect square. Okay, so let's do the first part. So let's find the square root of 10,368. Let's see what we get. So 10,368. So let's make pairs on the right. So 1 is left alone. So we'll start with 1. 1 is a 1. Subtract. So we have nothing left. We'll bring down 0, 3. We'll add 1, 2. What number should I multiply? This is 3 only. So we'll take 0. 0 is a 0. To bring down 3. Then we'll carry down 68. And what number should I take here? We'll add 0. This will become 20. And what number should I take and multiply to make it 368? We'll not get 368. So 201. 1 is a 201. Subtract. We'll get 167. Now see, we still have a remainder, means if I take a decimal point and increase the decimal numbers, decimal places, so the answer will come in decimals. Means if I try to square 101, I will not get 10,368. Means it is somewhere between 101 and 102 square, right? Now since we have a remainder, so we can say therefore square root of 10,368 lies between 101 and 102, isn't it? Because if we had divided further, we would have got the answer in decimal. So it lies somewhere between 101 and 102, the square root of 10,368. But they have asked us not to find the square root of this, but what number should be added to make it a perfect square. Now we saw that it was not a perfect square, but it is lying somewhere between 101 and 102. So let's see the next number, because if I square 101, it will be less than 10,368. It is lying somewhere between, so we need to square next integer, that is 102. So what will the square of 102? So 102 square will be equal to 10,404. Now you can find the square of 102 by multiplying 102 by 102, or you can use the algebraic formula that you have learned. So 102 square is 10,404, that is more than this, but this is a perfect square number, right? Because if we find the square root of this number, we'll get 102. So how much is 10,404 more than 10,368? Means we'll find the difference. That number should be added to this to make it 10,404. It will become a perfect square, right? So hence the least number to be added will be equal to 102 square minus 10,368, right? So this is the next number, next square root you can say, or the number which we square will get a perfect square, because the square root of 10,368 was lying between 101 and 102. So we'll find the square of 102. So what is the square of 102? 10,404 minus 10,368, which will give us 36. So the least number that needs to be added is 36 to make 10,368 a perfect square. Clear? So let's look at the next part, that is what number should be decreased from 10,368 to make it a perfect square. Now we have already found out the square root, and it was lying somewhere between 101 and 102. So we can say, since square root of 10,368 lies between 101 and 102, right? So the least number to be decreased, because the perfect square, next perfect square will be what, which is lower than this or less than 10,368, will be the square of 101, right? So we have to decrease it. So we have to decrease 101 square from this, and we'll find the difference, that how much number should be reduced from this. So decreased, the least number to be decreased to make 10,368 a perfect square will be equal to 10,368 minus the square of 101, right? Now we have to find the number that needs to be decreased to make it 10,368. So 10,368 will be more than the square of 101, that is 10,201. Now if we subtract, we'll get 167. That is the answer. So the least number that should be decreased or subtracted from 10,368 to make it a perfect square will be 167. Means we have to make 10,368 10,201. So if we subtract 167 from this, it will become 10,201, which is a perfect square, right? Next, Find the least number by which 10,368 should be multiplied to make it a perfect square and should be divided to make it a perfect square. Now we have to find a number, a least number, which I can multiply by 10,368 to make it a perfect square, and a least number which I can divide 10,368 by to change it into a perfect square. Let's take the help of prime factorization. So let's prime factorize 10,368. So now we have found out the prime factorization of 10,368 and we have represented 10,368 as a product of primes. Now with the help of this only we can understand which number needs to be multiplied to 10,368 to make it a perfect square. Now if you see the pairs which we use to find the square root, so here 1 2 is left alone, there is no pair for it. So this 2, if I multiply another 2 with this 2, then only it will form a pair, right? So the number to be multiplied to this number will be 2. Now let's write it in the form of exponents. So 2 square multiplied by 2 square multiplied by 2 square to the power 1, 3 square and 3 square. So if I just write all the exponents together for 2, so it will be 2 to the power 7 and 3 to the power 4. Now we know that any exponent, if it is odd, means it wasn't a perfect square. If it was to be 2 to the power 8, then we could have understood that this was a perfect square, because we would have got some pairs here, but here 2 is left alone, there is no pair for it. So what we need to multiply to make it a perfect square now? 2. So by multiplying 2, we get 2 times 10,368, that will be equal to 2 times, let's write 10,368 in the form of exponents that we have 10, 2 to the power 7 into 3 to the power 4, 2 to the power 8 it will become 2 3 to the power 4. Now let's take out the squares and make it a whole square. So 2 4, and I can write 2 to the power 4 whole square, that means 2 to the power 8, and 3 square whole square I can write, that means also 3 to the power 4, and take the whole square in common both the numbers. So 2 to the power 4 into 3 to the power 2 whole square. So 2 to the power 4 is 16, 3 to the power 2 is 9 whole square, 16 9 is a 144 square. So if I do 144 square, we'll get a perfect square number, right? So if you simply multiply 2 with this number, that number that you will get is a perfect square number. Now we have represented it in the form of exponents. Now this way of showing that, we'll clearly understand that if I square this number, it will be a perfect square. Okay, so we can say hence the least number to be multiplied is 2. Clear? Now using the same prime factorization, we will be able to find the least number by which 10,368 should be divided to make it a perfect square. So here look at the product of primes. Here again, if we form pairs, we'll see that 1 2 is left alone. So that very 2 is multiplied here. If I remove this 2, then remaining will be in pairs, right? So what is the opposite of multiplication? Division. So if I divide by 2, then the remaining number will be in pairs, factors will be in pairs, and it will become a perfect square. So 10,368 should be divided by 2, right? So let's see what we get by dividing. So if I represent, first let's represent this as a in the power form. So here how many 2's are there? 7, right? Multiplied by 3 to the power 4. Then by dividing 10,368 by 2, we'll get, so let's divide 10,368 by 2. We can use the expression of exponents. So 2 to the power 7 into 3 to the power 4 whole divided by 2. Now this means what? 2 to the power 1. So 2 to the power 1, and we can cancel out one power, that is, so it will become 6. So is equal to 2 to the power 6 into 3 to the power 4. Now we can take square common. So 2, this will become 2 to the power 3 and whole square. So 2 3 is 6, that means 2 to the power 6 into 3 square whole square. So 2 to the 4, 3 to the power 4. So now let's take the square common. 2 to the power 3 into 3 to the power 2 whole square, that will give us 2 to the 4, 4 to the 8 multiplied by 9 whole square, which means 9 8's are 72 whole square. So if I square 72, I'll get a perfect square number. So by this expression I can understand the result will be a perfect square, right? So after dividing 2, we'll get the perfect square number from 10,368. So hence the least number to be divided is 2. It's like the same number that was multiplied, that same number will be divided. Clear? So find the smallest perfect square divisible by 6, 8, 10 and 12. So we have to find the smallest perfect square. Think of it like finding the LCM, right? When we used to find the smallest number which is divisible by the given numbers, we used to find the LCM. So here also let's find the LCM. So solution, LCM of 6, 8, 10 and 12. Let's find 6, 8, 10, 12. 2 3 is 6, 2 4 is 8, 2 5 is 10, 2 6 is 12. We'll bring down 3, 2 2 is 4, 5, 2 3 is 6. Now 2 cannot go, so 3 1 is 3. We'll bring down 2, 5 and 3 1 is 3. So LCM is what? LCM is equal to 2 times 2 times 3 times 2 times 5. Now with the help of this only we'll be able to find the perfect square number, or the smallest perfect square number that will be divisible by 6, 8, 10 and 12. Now we have found out the LCM, right? So if I multiply this, 2 2 is 4, 4 2 is 8, 3 15 and 8 15 is 120. So 120 is the LCM. So LCM of 6, 8, 10 and 12 is 120. But they have not asked for the LCM. They have asked for the smallest perfect square number that is divisible by all these numbers. So with the help of these factors only we'll be able to find the smallest perfect square. Now look at the pairs that we can form here. So we see that here 2 has a pair, but 3, 2 and 5 they don't have any pairs. So we are short of another number, or you can say pair for these numbers. So 3 to the 6, 6 5 is a 30. So we are short of 30. So if I multiply 30 to this number, the entire number will become the perfect square number, right? So number, therefore number to be multiplied is 3 to the 6, 6 5 is 30. So we can multiply 30 here. So 2 into 2 into 3 into 2 into 5 will just multiply 30 here, or we can break it down like 3 into 2 into 5 because we needed a pair, right? So we have a pair for all now, so we can write it as 2 square, then another 2, have 2 square, then 3 square and 5 square. If I multiply these, we'll get the perfect square number. So 2 to the, that we have 2 to the power 4 into 3 square into 5 square. So 2 times 4, that is 2 to the 4, 4 to the 8, 8 to the 16, multiplied by 9 into 25. So on multiplying, 16 nines are 144, and then 144 multiplied by 25 will get 3600. So the smallest perfect square divisible by 6, 8, 10 and 12 is 3600. Clear? In a garden, 189 rose plants are arranged in such a way that there are as many rows as there are plants in each row. Find the number of rows in the garden. Now we have to understand the question. There are as many rows as there are plants in each row. Let's take for example, if there are 16 roses, okay? So if I tell you arrange these 16 roses, that number of rows that you put in each row, that should be the number of rows that you should have. So if I take 4 rows in one row, then I should have 4 rows. 1, 2, 3, 4 rows. If I have taken 4 plants, 4 roses in one row, then I need to have 4 rows. So here if I take 4 rows, then let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So entire 16 rows is perfectly arranged here in 4 rows. So 4 rows in one row and that many rows we have. So here similarly in this question they are asking, there are 1089 rose plants arranged in such a way that there are as many rows as there are plants in each row. So how will you find? Just imagine if it was 16 here, how did you get 4 rows and 4? So if I find the square root of 16, I'll get 4. Similarly, if I find the square root of 1089, I'll get the number of rows in the garden. That many rows, as many rows in one row. So let's find the square root. So square root of 1089. So let's make pairs. The first number will 3. 3 is a 9. Let's subtract. So we'll get 1. Carry down 89. So we'll add 3. 6. What number should I multiply? So we'll take 3 times 3 will give us 9 and 18. 189. So there is no remainder left now. So it has, so 1089 was a perfect square. So this is the square root of 1089. So we can say square root of 1089 is equal to 33. Hence, the number of rows is 33. Clear? Find the greatest 6-digit number which is a perfect square. Now for this, let's write the greatest 6-digit number first. So the greatest 6-digit number is what? 9,99,999. Now let's find the square root of 9,99,999. So we'll use the division method. So let's pair it. One pair, two pair, another pair. So what is the first number that I should multiply in order to get 99 or maybe less than that? 9, right? Because if I do 10, that will be 100. So 9 9s are 81. Let's subtract 81. We'll get 18. Then we'll bring down the next pair, that is 99. So it becomes 1899. What I multiplied? 9. So we'll add 9. 18. Now what number should I take here and multiply the same to get 1899 or less than that? We'll take 189 times 9. We'll get 1701. Let's subtract. So we'll get 8, 9 and 1. So we'll bring down the next pair, that is 99. Now what did we multiply here? 9. So we'll add. What will we get? 9 plus 9 is 18. Carry 1, that is 9 and 1. So 198. And what number should I take here and multiply to get close to this number? Let's multiply by 9. So after multiplying by 9, we'll get 17,901. So let's subtract. Get 8, 9, 9, 1, that is 1998. Now see, we have a remainder left. Now the number was not completely divided. So if I find the square root of this number, means we have to go into decimals now. But we don't have to cross this number because we have to find the greatest 6-digit number which is a perfect square. Now we have got the greatest 6-digit number, but this is not a perfect square. So if I go over it, that will be a 7-digit number. So we have to find a number that is a 6-digit number. So if I try to find the square of 999, that will be the result, or you can say that will be the perfect square, which will be a greatest 6-digit number. So instead of just finding the square of 999, we can subtract the remainder from the largest 6-digit number. Now if I square 999 and add the remainder, I will get the largest 6-digit number that we have divided just now. And simply to find the square of this, we can subtract. Let's do it. So we can write, therefore, if I square the 999 and add the remainder, what was the remainder? 1998. Then I'll get the largest 6-digit number, that is 9,99,999. Now if I have to find the square, what did I say? That we can simply subtract the remainder from the largest 6-digit number. So we can say 999 square is equal to 9,99,999 minus 1,998. So the square of 999 will be 9,98,001. So instead of multiplying 999 by 999, we can simply subtract the remainder and we can get the answer. So 9,98,001 is the greatest 6-digit number, which is a perfect square. We can write hence the greatest 6-digit number which is a perfect square is 9,98,001. Here, find the value of square root of 0.0025 divided by 0.0196. So what we can do here, we can simply change the decimal into fraction, right? Here we can see we have 4 decimal points and here also 4 decimal points, so it will get cancelled. Let's do it the other way. So if I say 0.0025, I'll change it into fraction. It will become by 10,000, right? And we had 0.0196, so 4 decimal places, so it will become 10,000 and 10,000 cancelled. We could have changed it directly, but I'm just showing it to you. So square root of 25 by 196. Now what is now you know that we can distribute the square. We can square the numerator separately and we'll find the square root of numerator separately and we'll find the square root of denominator separately. So that will be equal to 5 by square root of 196, that is 14. This is the answer. Now there are multiple ways of doing this, right? So you can multiply 10,000 to the numerator and multiply 10,000 to the denominator, or simply you can see 4 decimal places on the top and 4 decimal places on the bottom, so you can simply cancel it out, or you can do it this way. Clear? Find the value of square root of 1 minus 64 by 289. So here, before finding the square root, you simply subtract 64 by 289 from 1. So square root of 1 minus 64 by 289, let's find the LCM. So it will be 289, then 289 minus 64 square root. So 289 minus 64 will give you 225 by 289. So now you can find separately the square root of numerator and denominator, so which will be square root of 225 and square root of 289. So square root of 225 will be 15 and square root of 289 is 17. This is the answer. Find the value of square root of 9 by square root of 0.09 plus square root of 16 by 0.16 plus square root of 25 by square root of 0.25. Now what you can do here, you can find the square root of 9 or you can leave it like that. There are multiple ways of doing it. So look at 0.09. We can change it into fraction. So we can say square root of 9 by 100, right? Plus square root of 16 by square root of 16 by 100 plus square root of 25 by square root of 25 by 100. Now we can find the square root of numerator and denominator separately. Now 9 by 100, so this implies that square root of 9 by square root of 9 divided by square root of 100, right? Plus square root of 16 by square root of 16 by square root of 100 plus square root of 25 by square root of 25 by square root of 100. Now by means this will go up, right? This is the main division. So square root of 9 by square root of 9 into square root of 100 plus square root of 16 by square root of 16 into square root of 100 plus square root of 25 by square root of 25 into square root of 100. Now you can see simply the squares will get cancelled. Square root of 9, square root of 9, 16 and square root of 25, because the result will be the same. Now square root of 10 is what? 10. Square root of 100, sorry, square root of 100 is what? 10. Square root of 100 is 10 plus square root of 100 is 10, which is equal to 30. This is the answer. Now there are multiple ways I said you can do. You could have found the square root at first and then you could have cancelled. That way also you can do. Find the value of square root of 382 plus square root of 341 minus square root of 289. Now in this we have to go in the order from right to left. First find the square root of 289. So let's do it. So let's write it down again. So 382 plus square root of 341 minus square root of 289. So let's find the square root of 289. What will the square root of 289 be? 17. So let's write it again. 382 plus square root of 341, right, minus what is the square root of 289? 17. Now let's subtract. So square root of 382 plus square root of 341 minus 17 will give us 324, right? Now we'll find the square root of 324. So square root of 382 plus what is the square root of 324? 18. So finally we'll find the square root of 382 plus 18. So 382 plus 18 will give us 400. So square root of 400 is 20. So 20 is the answer. I hope it is clear to you. Practice the questions. Thank you.